Like I said, the topic of today, time. What is time? People usually don't, in school, they usually don't define time. They'll just say time is measured in seconds, other units for time. But I think this is the right definition for time. So time, this is the change. I want us to take note of this. This is the change. So if you talk of time, you're talking of the change. You can't know that time has passed until or unless you see the change. So we get to know that time is passing if we see plants growing, you know, our siblings or ourselves, so to say. When we get to increase, when we experience change, that way we get to know that time has passed. That's why we are defining time today as this is the change or the what? The interval over which change occurs, or the interval over which events occurs. You can put it like that. So it's just one and the same thing. So we are talking about change here. So time, if we talk of time, we are talking of change that usually happens in intervals. So events, today's event, tomorrow's event, there will be time passing there, and that's what we call time as well. So not only that, I'll also talk about what the SI unit of time is. The SI unit of time is second. So in short, time is measured in second. Yeah, and this is the standardized units for time. So these are the units that are used like everywhere. Yeah, so we'll have time SI, meaning International Standard Units. So these are the standardized units. And we also have other units that are used, which are minutes, hours, days, months, years, century, whatsoever. So we have all those. Those are other units for what? For time. So we'll be using these seconds because most of the formulas that we'll be doing were proved using seconds. That's why we'll be using seconds. But if the formula, let's say if the formula on electricity, time is used in hours, we use time in hours. So if it is in minutes, you have to convert it in hours. But in these other topics, you find that time is being used as in seconds. When the time I'll be giving formulas, I'll be showing you how important the conversion will be. So we can convert. I'll come talk about conversions later on in this video. And then the other thing we have to know about time is that time is the measurements of time. Time is measured in what? Sorry, the instrument used to measure time is what? We have the clock, we have the watch, stopwatch, and the pendulum. Today I want us to talk about the simple pendulum. So for the simple pendulum, it is called simple pendulum because it is just simple. Yeah, it is just made up of a string and a bob. So a string and a bob, a string tied to a bob, and then it attaches to a ceiling or anything. Yeah, which is stationary. So it is called a simple pendulum that way. So under simple pendulum, there are 4 things that we need to know. We need to know the length of the pendulum. We also need to know the period of the pendulum. We need to know the frequency of the pendulum. We need to also know the oscillations of the pendulum. And also what usually affects the rate of the bob of the pendulum. So those are some of the things that we need to know. Those are the things that the examiners will come ask. For the physics, it's science paper 1. So science paper 1, section B, question 1. Mostly what comes there is length, time. If not time, then we have, what's this? We have density and all those. But these are some of the topics that will cater for question 1 in physics. So the only things that we need to know, or the only concepts that we don't need to know a lot of things here. All we have to know is, we just need to know the length of the pendulum. The length of the pendulum, we need to define, know how to define period and how to calculate for period on a simple pendulum, frequency as well as what? The oscillations. So I'll start with the length. As you can see here, I've illustrated something. Yes, here I've illustrated something. This shows the length of the pendulum. In my notes here, I've written the length of the pendulum is this is between the ceiling to the what? To the bulb, the center of the bulb. So meaning from the ceiling here to the center of the bulb there. So if, let me just do it like that. This is the length of the pendulum. So from the ceiling to the middle of the bulb. Not from the ceiling to downwards here. No, that's not the length of the pendulum. Or from the ceiling to where the string attaches the bulb. No. The length of the pendulum is this, which is that correct. I guess you get the point there. Yes. So that's the length of the pendulum. Let's move on. Talking of the period, we have the period here. Period is defined as the what? The time taken for one complete oscillation. So this is the time taken for this simple pendulum to make one complete oscillation, or the bulb of a pendulum to make one complete oscillation. So if we talk of making one complete oscillation, meaning we are going to, period will be given by what? As we can see, I didn't write the formula, but I'll be writing the formulas there. So this is our P, period. So we have period. Period, it's T. So we are told this is the what? This is the time. So time will be on top. Time taken for the what? For the bulb of a pendulum to make what? One complete oscillation. This is the units that we'll be using for period. Where T, we know T is period. T is P. Period in second. In second. Where small t is what? Time taken. In what? In seconds as well. N is what? Number of oscillations. Apart from this, there is another formula that we can use to calculate period, which is T is equal to the inverse of frequency. I can use these formulas when I come to do my examples. We can see how we use these formulas. Okay. I think it is clear here. Let's talk of the frequency. Frequency, if we talk of frequency, frequency is the number of oscillations made in 1 second. Or per second. Per means 1. Per second. So if we talk of frequency, we are talking of what the number of oscillations made per second by the bulb of a pendulum. So if we talk of frequency, frequency is given by F. That's the symbol. So F, now we are told to say this is the number. So number will be on top, just like the definition. So is the formula. Number of oscillation over what? Over time. Because we are told that this is the number of oscillation made, number of complete oscillation made per second, which is time. And there is another formula that we can use to calculate frequency if period is given, which is frequency is equal to the inverse of what? Of period. So where F is what? Frequency. Frequency is measured in what? It should be in S. N we know number of oscillation. N is number of oscillation. And then T, as usual, time, which is should be in seconds. So these formulas will only apply when we have these units. So if time is in minutes, you convert. Okay, our last point there, I think this is the point I want to emphasize more. Oscillations. How to count the number of oscillations. Oscillations. If we talk of oscillations, these are just swings. Right? If we talk of a complete oscillation, we are told to what is a complete oscillation. Let me just write this data. Okay. That. So we have A, B, and what? C. So these are more like shadows. Yeah. So meaning for this bulb of a pendulum, we have this bulb of a pendulum. If we talk of oscillations, we are talking of these swings. The swing from there to there, that's an oscillation. From there to there, it's oscillation. From there to there and back to there, it's oscillation. From there to there and back to A, that's the oscillation. So now how do we know the number of oscillations, or how do we count oscillations, and what is a complete oscillation? So a complete oscillation, if we talk of a complete oscillation, we are talking of this bulb moving from A to C. So obviously to pass through B, A through B to C, and then going back to A. That's a complete oscillation. So one complete oscillation is from here, there, and back. Talking of a half oscillation, because sometimes the diagrams will be given to say the bulb moved like that. This is a half oscillation. Why? Because the bulb is just moving from A to C. That's half oscillation. So if the bulb moves from A to C, it's half oscillation. What of if the bulb moves from A to B? Like that. That's a quarter oscillation. We can see that. So meaning if the bulb moves from A to C, that's quarter oscillation. From B to C, that's another quarter oscillation. Quarter, we know it's 1/4. So 1/4 plus 1/4, we are going to have half. I think we can see where the half is coming from. It's quarter plus quarter, having a half there. So A to C, that's C, half oscillation. A to B, quarter. B to C, quarter. What of A to C and D to B, back to B? So for that one, we are going to have 3/what? 3/4. 3/4. So meaning from A there and then back to B. We are going to have, because here we are going to have quarter, there, quarter, and another quarter. So if we add these 3 quarters, we are going to have 3/what? 3/4. So meaning the number of oscillation, if the diagram was given and then the arrow was shown to say the bulb moved from A to C and came to B. So we are going to say its the number of oscillation was 3/4. Now these fractions, we won't be using this fraction. Yes, we won't be using this fraction. So since we won't be using this fraction, let's use the numbers that we'll be using, right? So for the numbers that we'll be using, this fraction, if we convert the fractions into decimal numbers, we are going to have quarter will be 0.25. Even there it will be 0.25. Coming back there, we are going also to have 0.25 there. We see? So 0.25 plus 0.25, obviously the half now will be 0.5. What of now half plus this 0.25? So meaning 3/4, where we move like that and that, we are going to have in decimal, it will be 0.75. And then coming back to A, just like we said, that will be a complete what? Oscillation. I think we can see that. That's about oscillations. Okay, from here now, let's do some examples. Let's do some simple examples so that we can see how to apply this concept we've just learned today. Okay, so this is our example. So the diagram shows a pendulum oscillating, supposed to be oscillating between position A and B. It takes 3 seconds to go from A to C back to B. What is its first period, second frequency? So this is how the diagram will be given. Sometimes they won't give the diagram, they'll just explain to say it moved this, or maybe they'll just give the number of oscillations and then you'll be told to calculate period and frequency. So these are the only 2 things that they'll ask to calculate for, mostly in papers, in exam papers. All right, so now we are told to say the diagram shows a pendulum oscillating between position A and C. We know that we have position A and C, and B also. Yes, but the B is just the middle point where the bulb was passing. Okay, so it takes 3 seconds. We are told that it takes 3 seconds to go from A to C. It takes 3 seconds to go from A to what? To C. Back to B. So meaning the time it went from A to C and it came back to B. What is its period? So we said period solutions. We write the formula. Period, we said this is the what? This is the time taken for the bob of a pendulum to make one complete what? Oscillation. So this is the formula. So for us to calculate period, we have to know what time is a number of oscillations. So that will give us now a clue on what should be on our data. So what are we given here? So what we are given, we are told to say that it takes how long? 3 seconds. So the time here we are told that it took 3 seconds, sorry. 3 seconds to go from A to C back to B. So meaning from A to C. If you remember, we said this will be our 0.25 and this will be our 0.25 as well. And then this again, that's a quarter, so it will be 0.225. So that's the number of oscillation. We're just going to add those and then we'll get the number of oscillations. So 0.25 plus 0.25, that's what? 0.5. Plus 0.25, that's what? 0.75. So the number of oscillation will be 0.75 there. That's the number of oscillation. So now, obviously with this data, we can calculate for period then. So what would be our period? Period, same time, 3 over 0.75. So 3 divided by 0.75. What would be the answer there? What would be the answer there? The T there would be what? 4. Yes. 4 seconds there. Think we can see how that is done? B. Frequency. Frequency, we can use this, but the danger of using this is that it can affect what? It can affect your answer if it is wrong. It will affect your answer if it is what? It is wrong. So, what are we going to do? We are going to say frequency is equal to, we said frequency is equal to number of oscillations made per what? Per second. So what will be our frequency there? What is the number of oscillation? We are using the same 0.75 divided by what? Divide by 3. So let me just use the calculator there so that we can see. So we are told 0.75 divided by 3. The answer there would be F is equal to 0.25 what? Seconds. Oh, sorry. Hertz. Frequency is measured in hertz, just like we said. So we can see how to calculate. So this will get simple if we get to know the concepts. So the important thing here is just the concept. If we get to know how to get all these things, you'll find that these questions, it will be easy for us to attempt these questions. Okay, I think this is where I end my lesson. If you enjoyed the lesson, don't forget to subscribe and hit the like button. And also, if there is anything that I can help in sciences, please let me know in the comment section there. Have a blessed day.